With a Snapmaker U1 release, people voted with their wallets for an affordable tool changer. Meanwhile, Bambu Lab took a very different route with their H2C. Was this decision made with a clear purpose, or was it just a miscalculation? My goal for this video is to compare both machines in terms of print quality, convenience and features, examine the strengths and weaknesses of both designs, and find out who are they actually made for. First of all, we have to look at the tool and hot-end changing systems. In CNC machining, automatically picking a different end mill is called tool changing. So why isn't picking a hot-end called that too? You see, a tool is usually considered a piece that can be picked up and instantly do the work. By picking a hot-end, we're missing an essential component, the filament. If all hot-ends already had filaments loaded into them, that would be considered a tool changer, as it would allow us to pick one up and instantly start printing. Bambu Lab H2C is not a pure hot-end changer, but rather a hybrid of both designs. For the hot-end on the right side, it has to cut the filament, change the hot-end, unload the old filament and load the new one. This is definitely a lengthy process, but H2C always has the ability to switch to the left hot-end, which is always loaded with filament and ready to go. Because of this, choosing the color that is used the most along the Z-axis leads to a significant print time reduction. In comparison, a pure tool changer Snapmaker U1 cuts this time down even further by 20% in this realistic print scenario. However, it all depends on how many times in a layer you have to change colors. With frequent 4-color changes, the printer will spend a lot of time rolling filaments back and forth, so print times can be nearly 2 times slower with a Snapmaker U1 tool changer design. So when it comes to raw speed, I would say that H2C print times are not game-breaking with realistic models because of that hybrid design, which gives the ability to quickly change to the left hot-end for the most used color along the Z-axis. But if speed is the #1 requirement for your needs, U1 and tool changers in general will be unbeatable. However, the weakness of the most common tool changers is that they require many more toolhead components, which raises cost and requires much more space. One of the most overlooked parts that makes or breaks great looking print surfaces is the extrusion system. I tested all 4 Snapmaker U1 toolheads and none of them provided results that I could call great, but rather quite average. Dual drive gear extruders are highly susceptible to giving such results if gears are not manufactured with extremely low tolerances. So while you won't see a significant difference in quality on more organic prints with a lot of details, since they hide imperfections, any print with a flat surface won't look great. When it comes to multicolor and material prints, perfectly aligning the nozzles is yet another important print quality factor. To test that, I designed a universal plate to attach any parts I wanted. It was manufactured by today's video sponsor, PCBWay. Because I don't want any grease or rust on my printer's build plate magnet, I chose stainless steel 430. It doesn't rust and it is magnetic, so it sticks very firmly to the bed. I've made a lot of builds with PCBWay services, so if you need advanced manufacturing for your own projects, make sure to check them out. As you can see, I made a custom stand for a microscope that allowed me to change tools and move them to the same spot to judge how well Snapmaker U1 calibrated its nozzle location. It runs Clipper, so it is very easy to control from the web interface. I recorded a video and took screenshots of each toolhead nozzle. The circles represent a range from 0.4 to 0.1 mm in diameter. As you can see, none of the nozzles deviated more than 0.05 mm, which I would say is a great result. We can feel even tiny imperfections with our fingertips, and while you can still feel a tiny amount of variation, such a small amount doesn't lead to any visual noticeable reduction in print quality. However, I quickly realized that it would be impossible to perform the exact same test with the H2C, so I went back to the basics, sliding the print at the filament change sections and measuring with a dial indicator. It showed that both printers do more or less equally great job of aligning the nozzles. The fact that the only way to show their performance is like this, and not just by visually inspecting the print, should tell you the full story of how good they are in this aspect. This leads us to vibration compensation and how well both machines reduce artifacts in the prints. Here, the rigidity of the motion system leads to more predictable vibrations that can be compensated more easily. H2C proves that with clean prints up to 10K acceleration values, despite having big and heavy toolhead. Snapmaker U1 results are a little bit disappointing, as it has artifacts even at low printing accelerations. I fully understand that these machines are in different price category, but as a buyer you should know exactly why, so you can make a more informed decision based on your needs. The same goes for the most annoying VFA or vertical fine artifacts that can ruin the look of a prints. All H2 series printers use belts with a smaller pitch diameter, which leads to less visible artifacts. In comparison, Snapmaker U1 results with a higher pitched belt just won't look as clean on flat surfaces. With that said, both machines have reliable bed leveling for those all-important first layers, and detailed model prints look good on both. The only other difference you'll see in improved print quality with H2C is with overhangs. It has a more powerful fan, so it can cool PLA quickly, while U1 is more on the average side. But print quality is only one aspect of 3D printing. Some say size doesn't matter, but when I have to print additional brackets just to barely fit the Snapmaker U1 on my shelf, which has only a small build plate increase over X1C, I would say size definitely can matter. Tool changers just take a lot of space, especially vertically. This makes enclosing the printer a more difficult task. It requires almost as big box as the whole printer itself. DIY printers like Warren's are known for how space efficient they are when comparing build plate volume to printer size, but tool changers probably take the last place in this category and require the most real estate. Meanwhile, H2C's implementation of a HOTEND rack takes up very little space. In fact, Bambu Lab packed it so tightly that you can easily end up hitting and knocking off HOTENDs when removing or adding the flex plate. So, when it comes to the space-efficient form factor and overall aesthetics, HOTEND changers will most of the time take the crown. But I feel like this isn't a huge factor. Most of us can live with a bigger printer. Where many of us want real improvements is convenience. I have been using both printers for a while, and I have to say that once you get used to any automatic material management system, it is so hard to go back. If you only print PLA, leaving spools on the sides in the open, it is not that big of a deal. But even printing PTG requires you to print it out of a dry box, as PTG absorbs moisture and that ruins print quality. It is great that Snapmaker Official offers such an option in collaboration with Polymaker. I tried making convenient dry box setup with custom printed plates on the filament feeders, but I still felt like I was back in my early days of 3D printing compared to AMS systems. It is like going from 120Hz monitor back to 60Hz. Once you tried it, you don't ever want to go back. I feel like the other companies underestimate how convenient these systems are. The question is, where do you put such AMS-like units on a tool changer? Putting them on the top would basically turn into tower, and filaments would be hard to reach, and putting them on the sides would take even more space. Probably the most reasonable solution would be custom designed units that mounts on the sides, handle loading and unloading, and drive the filaments. You might be asking, why would you want to unload filaments from a tool changer anyway? Well, because the filament path inside the PTFE tube is not an airtight system. Filaments absorb moisture, and when they are under prolonged bending stress inside PTFE tubes, they can just snap. Rolling the filament back into the AMS unit packed with desiccant eliminates both of those problems. Plus, it allows for an instant filament swap without needing to wait for each toolhead to heat up, retract, and only then manually pull out the filament. Repeat that 4 times when loading different colors and it gets old quickly. And it's even worse if you have to fiddle with the filaments in dry boxes. So who is each machine made for? Starting with Snapmaker U1, this is mainly a printer for fast up to 4-color PLA prints. If you mostly print models with a lot of details, we will look basically as good as with H2C. But don't expect the same quality on flat surfaces, they won't look nearly as clean. When it comes to convenience, I would say Snapmaker U1 mainly lacks it if you won't print anything but PLA. With PLA you can leave filaments on the sides if you are in a dry environment. Each time you want to change filament color, you have to wait for the HOTEND to heat up and do retraction because there is no filament cutter. Well, this is not a deal-breaking inconvenience. If you want to print PTG, you need a dry box. But dealing with manual filament management in dry boxes in 2026 is definitely not the way if you seek convenience, especially dealing with 4 filament rolls. The better way would be side-mounted AMS-like units that would do all fully automatically and can also dry the filaments. A positive surprise was that the U1 comes with automatic pressure advance calibration just like Bambu H2 series printers. For the most part, both machines handle the automatic filament calibration well enough when starting the print. With U1, defects are just harder to see because of the less consistent surface finish. When it comes to noise levels, U1 is an open type printer, so you will hear more noise compared to all H2 series printers, which are much quieter. But with H2C it can still be disturbing, as it can constantly pick up to 70 decibels during filming changes for the right side hot ends. Taking the price into account, from my testing, the Snapmaker U1 is a great and reliable machine for people who mainly print detailed multicolor PLA models. Just don't expect much more, it does one job and it does it well. Meanwhile, H2C sits on a completely different end of the spectrum. It is the jack of all trades. You would think it should also come with the words master of none, but Bambu Lab's print quality with these H2 series printers is almost endgame level. There's not that much left to improve, even by my insane print quality standards. Consistent extrusion, effective vibration compensation, and very low vertical fine artifacts all lead to great looking prints. Even inductive hot ends for the right side produce similar levels of melting performance as resistive heating hot ends on the left side. H2C is not on the same level as pure tool changer speed-wise, but it offers up to 7 colors if we exclude purging different colors through the same nozzles. It comes with an MS unit, but it only has one filament outlet port, so if you want an automatic filament management for both left and right hot ends, you will have to empty your wallet even more, with additional MS2 or MS HT units, plus more 0.4mm inductive hot ends to get those 7 colors. If you're a person like me who mainly prints functional parts with a variety of materials, you will find H2C to be a more effortless way of 3D printing. No need to change hot end size manually, it picks different size hot ends like 0.2, 0.4 or 0.6mm automatically. I can make prints with support materials, I can keep the chamber and hot end temperatures high for engineering filaments, and I can drive them in MS-HT units, and so on. Combine that with somewhat competitive print times on realistic multicolor models, and you can see why I call this a jack of all trades. It literally does everything if you don't mind paying for that quality and convenience. Hopefully this gives you an idea why I liked each of the printers, but for different reasons. If you enjoy the more educational side of 3D printing in my videos, consider supporting my work on YouTube or Patreon. Huge thanks to everyone who already does that. Well, that's all from me, and we'll see you next time.